this video, we're going to look at building a microwave gun, and we're going to play around with it afterwards to see some cool things you can do with it. And just some history here, real quick. 1945, Raytheon, the company Raytheon, it's still around, was testing a magnetron, and they had been working on this for several years. They finally finished it in 1945, and they did that so they could use it to bounce microwaves off of planes and ships as a part of a radar system. And that's why the magnetron was originally built, and it was enormous. And then comes along within apparently a few weeks a guy named Percy Spencer, and this fella is walking around the lab while the magnetron is running, and he noticed that within a few seconds of being close to the actual beam, apparently he was lost. He noticed his candy bar melted. This is a true story. And so they messed around with that and found out relatively quickly, within a few years, that microwaves could actually cook food. It was a few years after that, around 1950, that they were able to make the magnetron smaller, and they were able to fit it into a box, and they were able to use a small metal box. It was relatively small compared to the unit, to put the actual food into that box. These units, when they reached the public in kind of the mid-1950s, were 5.5 feet tall, 750 pounds, and they cost $1,300 back then, which is something like, I think, 12 grand now. And obviously only the richer household has anything like a microwave oven. The countertop version was introduced in 1967, and we all know the rest of the history there. And in these countertop microwave ovens, there's a couple of things in there that are important that we're going to use to make our microwave gun. It's not going to look like that. Parts of a countertop microwave that make it work and are absolutely essential are the transformer, a large capacitor, a fan to cool everything, and the magnetron, which creates the microwaves. And then lastly, there's a waveguide. And this waveguide focuses the microwaves into the oven space, the metal oven space, whereby they bounce around and make cooking efficient. And of course, there's a switch to turn it on and off. So we're going to tear all of these things out of our countertop microwave. And of course, they'll be freestanding, so we need to have something in order to build our microwave. And we need a solid base to do that. And I highly recommend wood. Wood is lightweight, it's non-conductive, you can put screws into it and you can move them if you've made a mistake. It's just really easy to work with. The second thing is not here, because we're going to go over to Dr. Mr. Butane Fireball and see what he has to say.
Hello, this is Dr. Mr. Butane Fireball back with you today, and I'm here to talk to you about building a microwave gun. But before we do that, we got to go over a couple things here. We're going to talk about the electromagnetic spectrum, and I'll make it quick, I promise. So, the spectrum of electromagnetic radiation includes the visible spectrum, like everything around us. The light, the colors, that's all part of the electromagnetic spectrum. And the other thing is, none of this is to scale, so don't take that for something to be real, you know? Roy G. Biv is a name you should remember, because it tells you all you need to know about that visible spectrum on this electromagnetic line right here. And it stands for red, orange, yellow, green, blue, indigo. You know, you might have to look that one up. Violet. And those are all the colors that fit right in the middle here. But this spectrum is huge. It goes all the way from radio waves all the way down to gamma waves. And you got the most energetic wave down here with gamma waves. And you got radio waves down here, which you're probably getting hit with them right now, and you don't even know it. Now, you get down in the middle here, we got that visible spectrum, and then you go a little bit more, you got infrared, then you got the microwave, and then you got the radio wave. Now, that microwave is 10 to the minus 2 meters. It's about 12 centimeters, give or take, about 4.5 inches long. You know, that's how big a microwave is, right about. So, when that microwave, though, hits a drop of water, or a water molecule more like it is really, that thing starts to vibrating back and forth, because it's got a positive and a negative, and that microwave's coming along and it's bouncing it about, you know, pop, 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 pop. And when it bounces enough, it gets really warm. And that's exactly what happens when we cook our food, or heat up our soup, or whatever. That's the microwave that's doing that right there. And we can see microwaves are way stronger, way less strong, my bad, than gamma waves, because the gamma waves will kill you. But could you imagine if we had a gamma wave oven? Man. Okay, that'd be fast cooking for sure. So, we move down out here to this other line that I drew out here, and you can see the waves, they get all crunched up here where they're real full of energy, and then you get all the way down here where they're not quite as energetic like that radio wave I was talking about earlier. And you can see that a wavelength is when it goes up and then it comes down and then it goes up. That's one wavelength right there, and that's a microwave wavelength, 12 centimeters, okay? So, when you have to put together your microwave gun, see, this all has a purpose to it. Yeah. So when you're building your microwave gun, you got to have the right kind of thing on the end here to make sure that your wavelength of 12 centimeters doesn't just go flying everywhere, because that's not going to help nobody. You want something that's going to project it forward. Like, so in every microwave, you've got a waveguide, and that's built into the metal case, because you know that's just the way to do it. And you get that waveguide out to put over the end of that magnetron right there. Well, that's a bunch of work. You got to chop and hack and saw all kinds of stuff. It's a mess. I've done it before. So I think I got a cheat for that, though. I think this other thing will work. You know, it's like kind of available to everybody. You know, so we'll get into that a little bit later. So when you're building your microwave gun here, you got to have something sturdy, like a piece of wood, like he was saying over there. You know, and wood is perfect. So you take all your pieces that you got out of your microwave, and we'll be going into that a little bit here. You got your transformer, stands for key. You got C for capacitor, and you got M for magnetron, and that's for fan. Yeah, a basic fan right there. That's all that is. So you got to connect all these things in the right order here with all these wires in order to make this thing work right. And all them wires you probably can pull right out of that same microwave you destroyed in order to get these parts and pieces here, you see? So what you got to do is you got to run the AC voltage. That's AC over here, and it plugs into the wall. So this is all very kind of, you might say, dangerous. And then that power goes into transformer moves it over to capacitor. Capacitor kind of discharges into that magnetron. Magnetron shoots those microwaves right out in there. So you can see the microwaves, they do these little squiggy lines because they don't come right off the tip. That's what it would seem. But they don't. They come off the edges like in a little tiny circle, and they go like that. So when you put this together, you got to make sure that you ground 3 different things. 3 of them. The transformer must be grounded. The capacitor must be grounded. The magnetron must be grounded, okay? So I'm tired of saying must be grounded. So the only thing that don't have to be grounded is that fan right there. When you ground all these things and you put it into your plug in order to plug it in, then things work real good. If you don't ground something can go kind of not very good for you, okay? So you got to do this just right. And I think we covered everything on here. It looks like it. It's good to see you again. And yeah, that's about it. You have a good day now, sir and ma'am. Yeah, goodbye.
To start making our microwave gun, we need a microwave, of course, and like so many things, I found this on the side of the road. I have to show you the inside of this. It's a complete disaster, but the good thing is it does not matter because everything we need is covered by that nice metal case. Quick video, I took the cover off and you can see all the components are on one side. They always are. Here's a transformer. It was attached to the frame, so when I took it off, it fell out. That's why the tape is there holding it in place. And here is the capacitor. Very dangerous. It's the most dangerous part of the project here. You must discharge it by touching metal between the 2 ends there. And once you've done that and it discharges, you're fine. A lot of times when they're older like this, they've discharged on their own, but you cannot take that chance. The next step is to remove the fan, the transformer, the magnetron right there, and the capacitor, and wire them exactly like they are in here, but outside of the box of the microwave. The magnetron's going to get hot. You must use this fan right here, and I know from experience it's 120 volts, so we can cut the wires right there and just wire it right to the 120 volts when we're done. Follow this bundle of wires around. You find that there's a lamp down here and some heat switches. There's one right there, and then there's one right here. They're set to a certain temperature. Once they reach it, they shut the machine down for obvious reasons, but they're not that important for what we're doing, so we're going to cut them out. I took out a single screw right here, and then on the other end here of the housing for the fan, there's just tabs holding it in place, and you can see that one tab in the center here has a bend in it. I just need to unbend that, and then I can remove the fan. 1 down, 3 to go. The magnetron is held on by 2 screws there, and then 2 more on this side. I'm going to unplug the wires here, take out the screws, and we'll have the magnetron. Quick comment, before you remove wires, mark them in some way so you know how to put it back together later. Number 2 of 4, a couple things about the magnetron. If you want to take it apart for those ring magnets for other projects, I have a little stack here from magnetrons that did not work. And this is a barium ring right here, that red piece. And barium powder is extremely harmful to your health. So if you do take these apart, do not break that ring. Transformer right there. You can see there's two tabs where the AC power comes in. So I'll be detaching those. It's already quite loose. I don't think it'll be hard to get out. And then you can see the wires on the opposite end here that end up in the transformer. So this whole unit will probably come out as one. All the components are now out that we need. The last thing I'm going to grab is that fuse. I've collected all the parts here to the microwave. We're going to start on this end right here. There's the fuse I was talking about, and it's going to be connected through into the transformer through the AC power that goes in there and the AC power that goes into the fan right here. Then we have our capacitor here, and we finally have our magnetron, and here's where the microwaves are emitted right out there. One thing about the capacitor here is that they always have this large diode, and this diode directs the energy out of the capacitor into the ground of the housing of a microwave and then into the ground in the wall socket. This needs to be connected to the ground of whatever wire you're going to use to plug this whole thing in. So I cut myself a piece of 2x4 here. It's like 26 inches long, somewhere in there. This will work great for a base, like I was saying earlier. And we can take the magnetron right here. It's got these brackets nicely. We can put this on the end and screw that right down, which makes a great starting point. I scavenged a wire from the microwave that we had torn apart and put this eyelet on the end here, just crimped it down. I have a screw right here that fits nicely in there, and I'll be putting that down right here through that hole so that we can use this as a ground wire. Now that that screw is contacting bare metal and then into this wire right here, we know that the transformer is safely grounded. I did a few steps here off camera, not to bore you. So here's the fuse holder right here. I put one screw in there. I need to pop that fuse back into the holder, of course. And the other end of the fuse is attached to the hot going into the transformer. The other side here would be the neutral going into the transformer. Then down here, I am going to use the bracket for the capacitor, and I'm going to screw this to the wood down here and then attach to the bracket to the inside of this right here. Then moving up here, we have the diode that goes into the capacitor, and I put an eyelet on the end of another wire that I tore out of the microwave we destroyed and just screwed those two together, and that wire continues back all the way back here and is attached to the other ground wire that goes to the transformer. So the capacitor and the transformer end up grounded right here. So the electrical cord that I'm going to use, I put the ground here, I put the hot right there, and I put the neutral right there. So we have two of the grounds here that are screwed together that go into the ground of the electrical cord, and of course we have one more left. We need to ground the magnetron. I used a screw again to run this last ground all the way down. Still one thing that needs to be attached that's very important. That is the fan here. So I'm going to be building a bracket. Started by cutting off one of the metal flanges here, which just added weight. And as I was doing that, I realized I could cut off a large portion of this frame here. Now that's getting rid of a lot of stuff. I just dremeled it off, and I've completed the bracket for this fan unit up here. I just used paint sticks. I drilled some holes here and down here and did it on both sides. However, I found that the fan was too wide to fit between that bracket there, so I just snipped the ends off. It'll still work fine, and it freely spins. I use these electrical crimps here to attach the wires from the fan all the way down to the neutral over here, and also the hot right here that goes in here. So the fan is connected electrically, so is everything. And then I'm going to be putting this right here because we want to pick up our gun. All right, I got a couple of screws right there to do that. And then this will be put probably somewhere, let me see, in here on top of another piece of wood so I can pick it up in the front. It's heavy. It's probably a good 20-25 pounds. So now that we have all the ground wires put together here, I wrapped a bunch of wires here to protect my hand with this paper towel roll here. I cut it to wrap it around, taped it back together. Still have to put the handle here. This one's screwed in nicely. And we still need that waveguide. Lastly, we need to put the waveguide on, and I have my substitute here for the waveguide, and it's this. It's a shield for a lamp, and it simply goes right over here. It fits perfect. I've done this before, so I actually know it works. That as a waveguide, you need to raise your entire apparatus here. Otherwise, when you set this down, the shield there will hit the ground. So this makeshift waveguide from the lamp shield is in place. You can see the wires as they ran through the holes there. And then on the outside here, I wrapped the wires around these two existing holes in the magnetron and in the screws that we had placed earlier here So it's ready to go. With the metal lamp shield wired on there, I'm going to plug it in. Ah, that's not good. So the sparks we saw is the interaction of the metal shield with the actual microwaves, which you might see if you throw aluminum foil in a microwave. So I need to put some sort of insulation between the shield here and the magnetron. That sparking did leave a few marks there, but it should not affect the overall performance of the magnetron. So I guess what I'm going to do with this right here is cut this off, maybe a 1/4 inch down here all the way around, in essence providing a larger hole to go around the end of the magnetron right here. And also I'm going to be using this. This will work because it's a high temperature silicone by JB Weld. So in addition to making a larger hole, I'm going to glue it with this. So I cut the end of this off. If you put it back on here, you can clearly see there's a much larger gap between that gold metal ring and the metal guard here. I think that's going to help a lot. Well, this has become quite a thing. I'm using the high temperature silicone and spread it both on the inside there and the outside to separate the metal from both pieces there. The high temp silicone has cured, and I still wired the top and bottom just to make this real sturdy. It's set, so let's give this another try. This is take 2. I'm going to plug it in here. No sparks, that's a good sign. And the ultimate test, all right. And you can see how the metal shield blocks the microwaves easily, but directs them out front. Okay, excellent. So to start our testing with our microwave gun, I have an outlet there in view, and on a lot of newer homes they have the GFCI button that pops if you overload it. And another way to overload these easily is with our microwave gun, which I have right here. Pointed directly at it. It's pretty loud, I don't want to ruin it. But that's a good, probably 8 feet. This is the microwave gun that we just finished making, and I said I made this before and I had used this metal shade, and that's because I had, and it's this one right here, and I used the same metal shade from a lamp on this one. But I noticed something when I looked inside here, and that is that the gold ring on the inside here actually has this other ring protecting it that's built onto the magnetron, so that when I put this down, there's no way this gold area, which is where the microwaves come out, could even come in contact with this. So I didn't realize that, and I went ahead and tried this, and obviously it didn't work. We had to go through all this mess here to make it work, but it works nonetheless. So when I look at these two guns here, the old one actually has a lot of wiring. It's really a mess. I don't know what I was doing. It does work great, but it's really messy. And I streamlined this one a lot more, which I'm happy about. The only thing that's the same is the brace here to hold the fans up. They're both kind of funky. It's hard to pull a fan out and just make it work and fit and all that. But so yeah, I think I learned a few things making this new one here.